Hey everyone, welcome to this stream. So in the previous stream, we downloaded the data for we downloaded the Fruit 360 data and extracted it, and we also applied the model and we tried to fine tune it. So in this stream, we are going to continue optimizing our model. So let's try to find the learning rate. Let's try to just fine tune the model without any hyper parameter tuning. So while that is happening, let me get well, you already have it, so well, we can get it again. So after this is done running, we are going to find the learning rate. And this learning rate is going to be common for all the layers. And after that, we will try to unfreeze the freeze and unfreeze and do custom fine tuning. Let's also get the code to export the model. Yeah, it is learn.export. We are going to export it in my drive folder. So let's copy the path. We will call it roots1.pkl. Let me review what kind of optimization we can do. 12 inside pet breeds. Okay, so we can try to find the learning rate for all the layers and apply that learning rate and fine tune the model. After that, we can do unfreezing. Unfreezing, basically fine tuning does the unfreezing and freezing, but we can do all those steps manually using this. So we can fit one cycle. When we call fit one cycle on the learner, it first it applies, it fine tunes the parameters, the randomly added layers. So it fine tunes the randomly added layers for 3 epochs. Then we do the unfreezing, which will basically unfreeze the pre-trained layers, and we find the learning rate. Okay, so after unfreezing, we find the learning rate again and apply that learning rate to fit one cycle for 6 epochs, and this time it will train all the layers including the pre-trained layers. And after that, we also have technique of discriminative learning rates. So in this case, we are going to find, we are going to provide a range of values for the learning rate. We are not going to provide a single value, but we are going to provide a range of values which will increase as we move to the final layers. So for the previous layers, the learning rate will be lesser, because the previous layers are already pre-trained. We don't need to uh, train them that much, so therefore we are going to provide. So that's the idea basically. For the lowest layer, we provide less learning rate, lower learning rate, I mean. That's one technique, and after that we can choose the number of epochs. So that's not that much, complicated. So let this model run and we will see why is it taking that much time. This time we are getting 3000 images for the training set and 900 for the validation, which will suffice, I guess. Taking this much time, we are only providing 3000 images. Well, 3000 is a lot anyway. In this case, we are only providing 100 or 200 of values, so it's considerable given the number of images we are providing. What if I try to provide even a lesser subset of data? So what if I provide 0.03 for the training and half of that for not half, actually 20% of that much for the validation? Then it might again speed up the process. Let me try to do that. Let me provide 0.03 for training and much would be 20% of 0.03? 20% of 0.03. 0.0006 or something. Right, let's give that much then. Let me stop this fine tuning. Let's check the size of training and validation set. It didn't apply it. What? Why is it taking? Okay, we are getting now 958 for training and 191 for. Let's check the vocab as well. Wait, this time we are getting only 65 vocabs. So it is excluding most of the data, it seems. Did we lose the data again or what? Let me check. Let me check how many total images we have. We have 50. Oh, why do we have only 54,000? It should be 90,000 or something. Damn, did we lose the data again? It's alright, we're going to work with this much data this time. We don't need to get further data. We will work with 65 categories only this time. It's alright. Let me check the summary as well. So it found 31,000 items. Okay. Good. Now let's try to fine tune it. It has done one epoch and two epochs and three. Oh, it was quick for last two epochs. So we are down to 0.76. I don't think we need to save this. It's not good anyway. So let's try to use, well, what the hell, let's just save it and we'll see. Okay, now let's try to use the LR find method to find a learning rate. So it is going to give us this kind of graph. And we need to select a value from this range, from this strip basically. So we have got almost same kind of graph, and we need to select a value from this range. And if we compare the graph, it is almost similar, just it is just shifted a bit. So we can use the same learning rate, which is 3 raised to minus 3, which falls somewhere in, well, it falls in, let me see, it falls in this range. So let's try to use, we can use 4 e raised to 3. It will be somewhat similar, I guess. So let's get the learning rate learner, and let's now fine tune it for two epochs, and this time we are going to pass base learning rate for 4 e raised to minus 3. Good. All right, so it did improve a bit. We got 0.68 error rate. Now let's try to use, should we, well, no, it's okay, we can keep this learning rate. Now we will try to use this technique of unfreezing. With the fine-tune method does this by default, but we are going to do it manually. So let's first of all, let me save this model so that we don't lose it. We are going to call it fruits2 and LR find. Cool. Now that we have it, let's get the learner again, and this time we are going to, I'm not going to use the fine-tune method. We are going to use, let me open up this, the source code of fine-tune method, so that you guys can compare. So the fine-tune method does this freezing, then fitting one cycle. So basically freezes all the pre-trained layers, and after that it fits for one cycle. So this fitting cycle, in this fitting cycle, it only trains the randomly added layers, and it doesn't touch the freezed layers. And after that we half the base learning rate and unfreeze all the pre-trained layers as well, and then fit all the layers including the pre-trained layers for the number of epochs. Good. So that is what fine-tuning method does by default. We are going to do that same the same we are going to carry out the same steps manually. So let's do that. And we'll get fit one cycle first of all, and by default this fit one cycle does it for one, so freeze epochs does it for one, but we are going to do it for three, and we are going to pass the learning rate that we found earlier, which is 4 e raised to minus 3. Cool. Let's check the learning rate. So this is doing this kind of epochs. So we were down to 0.68 for the freeze epochs, and we are it actually, you know, it wasn't, it was made it worse. It is 0.75. It's okay, this is not the final result. Now we are going to unfreeze it, and after unfreezing it we are going to find the learning rate again. Cool. So now we get this kind of graph, which is almost similar to this graph, and we can select a learning rate from this range just before it starts to dip and get worse. That's what the author has selected as well. He selected 1 e raised to minus 5, so between this range we can select the same learning rate. We can select, I guess, 0.4 or something. You can select 10 raised to minus 4. So let's do that. Let's select that, and we are going to fit it for one cycle again, and this time we are going to select 6 epochs, and we are going to pass the learning rate to lrmax parameter argument, whatever you want to call it, and we are going to pass 1 e raised to minus 4 this time, because our graph is a little bit shifted than the graph from this notebook. So we can use this learning rate, and let's see what results we get for the final clock cycle. Not clock cycle, the cycle. Point 79, 0.78. What? It didn't even improve any further. It actually got worse. Got worse. 79 to 80. Let's try to do it again. It seems that we are not finding anything worthwhile. So let's try to find the learning rate again. Cool. We have got the same kind of graph. So it is almost flat up to 10 raised to minus 3, 10 raised to minus 3, and the loss starts to decrease from 10 raised to minus 3. So it decreases from this range. So let's use 3. We got 78 for the random weights, 0.79 for all the layers, 0.79. It didn't improve that much. Let's replace the previous model. Cool. Now let's use 3 here as well. We should keep this as it is for the reference, and let's run the code in new cell. This was for 4. Let's run it for 3. And 75. The results are almost same. Let's unfreezing and find the learning rate again. Alright, we have got the result, and we selected this learning rate, which is all right, I guess. Selected this learning rate. Let's try to train it for 8 epochs this time and see if it improves a bit or not. Seems the training loss is getting down, but the validation loss remains almost same. So does it mean we are overfitting the model? We are getting 0.70. So yeah, we are overfitting the model. And why is that the case? Why is it overfitting? So in this case, the validation loss was going down as well. but it remains constant for this. Maybe let's try to use the discriminative learning rate technique, and let's save this model for now, and we will get back to it again. Let's call it fruits 3, unfreeze, custom fine tune, custom fine tune LR fine. Okay, let's save this model. Cool. Now let's try to use discriminative learning rates method. For that, we are going to carry out the almost similar approach. We are getting the CNN learner first. I'm going to pass the data loaders, get the ResNet 34 model. Matrix remains the same, which is error rate. And we fit it for 1 cycle. We are going to provide, we are going to fit it for 3 epochs and passing the same learning rate that we passed previously. Now we are going to unfreeze it. Okay, the only difference is now when we do fit 1 cycle, we are going to fit it for 12 epochs, but now we are not passing a single learning rate, we are passing a range, a slice. So it will select multiple values of the range. Basically the range will start from 1 e raised to minus 6 and go up to 1 e raised to minus 4. Now let's try to see the result of this tuning. So the error rate is not budging even a single number. It remains at 0.82. It got up to 0.80. Okay. Started increasing gain. Point 80, 81, 82. So it is fluctuating between these rates. Got up to 0.79, which is not better than the previous model. Let's try to plot the learning rates. Plot the loss, I mean. Oh, what the hell? What kind of loss is this? Does it even decrease a bit? The validation loss remains at that range and the training loss remains at this range. So we are doing something terrible with our model. Is it because of the data? Do we not have enough data? Or is it because of the transforms? We're using a random subset, right? Which gives us 958 images for the training set. What if we use a denser model? Let's try to use a resonant 50 and check. First of all, let's save this model as well. We're going to give it name fruits 4. Let's call it discriminative learning rate. So custom, we are not custom fine tuning. Did we custom fine tuning? Yeah, we did it custom fine tuning. So it should be custom fine tune and DLR, discriminative learning rate. Now that it has been saved, let's try to use a resonant 50 model. Resonance 50 may iterate to FP16. Now we are fine tuning out for 6 epochs and phrase epochs 3. This time we are not providing different learning rates, so it will select whatever was by default. I hope it doesn't run out of memory. Point 70, 0.69. Okay, so that's a bit of improvement. 0.70 again. We got up to 0.7978. Even the validation loss is improving this time. Wait, we got up to 0.70 this time. Maybe we need to use a resonate 50. So let's try to use this custom method for resonate 50. Let me save this model as well. So this is for fruits 5, resonate 50. Now we should do we should try to find out the learning rate first of all. So let's use this code to find the learning rate for the random weights. So let me copy this. This will find us a learning rate. So we have got similar kind of slope, so we can use the same learning rate that we used previously, which was 3 raised to minus 3. So let's use that learning rate. We need to get resonate 50. So let's replace this learner and fine tune it for 2 epochs with the base learning rate 3 raised to minus 3. Okay, 0.17. Let's not save this model. Let's try to use the custom unphrasing and phrasing model. So we are going to first do fit it for 1 cycle, unphrasing it, LR find and fit 1 cycle. Right. So let me grab this model, and this time we are going to not use fine tune but fit for 1 cycle. Fit it for 3 cycles and wait, what's the learning rate argument? LRMX. Do we have to provide a LRMX? Well, yes, we can. So I'm going to pass 3 raised to minus 3 again. So I pass 3 e raised to minus 3 and let it fit for 1 cycle. After that, we need to unphrase it. Okay, we have got the results. Now let's unphrase the model. And after unphrasing, let's find the learning rate for all the layers. And that the learning rate that we find, we will use it in the last fitting cycle, which we will try to fit it for 6 epochs, and we will pass that learning rate to LRMax argument. Let it find the learning rate, then we will apply it over here. Right, we have got the learning rate. So I guess we can select this range, I guess. Should I select 10 raised to minus 4 or 10 raised to minus 5? Well, the loss did decrease rapidly on this range. Let's use 10 e raised to minus 4. 10 raised to minus 4, that means 1 e raised to minus 5. 0.727371. It didn't improve that much. What if we use the discriminative learning rates? We need to replace this model first of all. Let's check the results for the discriminative learning rates. This time let's also try to plot the confusion matrix. We got up to 72. It didn't improve that much. Let's try to plot the confusion matrix and get the most confused classes as well. The results look totally random. Wait, do we not have enough data? We have only 5, 3, 2. Oh, wait. It means for the category, we are not, it seems we are not using enough data, I guess. Let me plot the most confused. Let's also check which are the top losses. What was the function to plot the top losses? Okay, it's this one. It seems apple brother and delicious. So yeah, I guess that is the problem. We are not using enough data. It seems we have so many categories that we are missing most of them. Or maybe it is because we have lost some data from the dataset, and those labels are also getting considered. But the training dataset is same, right? We should select some more data and check if it improves our model or not. So let's try to train it for, I guess, just selecting 9500, right? Let me check the vocab again. We have 65. Let's use 0.2%, and this should be 0.5%. So that will give us so it gives us 6000 images for training and 1500 for the validation dataset. Let's now try to use those data. Let's use the simple fine tuner first of all. As we have increased the dataset size, it is going to take a bit longer to train. Internet connection. Alright, it is all right. Right, we have got a good connection. I think Google Colabs throttles the speed after some time. Maybe because I've been using the Google Colab today for I think 2 hours, more than 2 hours or something. It's starting to throttle the speed, I guess. It's even taking. It's not even done with the randomly added layer yet. With this speed, we won't be able to work further and fine tune our model. I got message from my internet provider that the internet is going to go down and I might see some blockage in the network. I hope that doesn't happen right now. Let me try to check other notebook. Maybe that will give us some idea as to why our model is not working. So this girl has used VGD16. Did she use all the data? She used test and split to split training data frame. Wait, what is inside training data frame? Well, let's see. She got the data, training data inside trainer and test data inside tester. Okay. Now she created a data frame. Wow, why did she create a data frame? And she passed columns as image path and class. Okay, she's just creating a data frame right now. And now she's getting all the file paths, image paths, and the class names. So she's creating a data frame from the data. Cool. Now she's splitting the training data frame. She's keeping 0.1% for the test size. So that gave her a validation data frame of 6,700 and 60,000 for the training data set. Okay. What is she doing now? Visualize number of samples in each class of training data. Okay, she's visualizing the number of samples. Top 10 classes in training data. She's doing data visualization. Okay, let's skip that. The data preparation steps. And she's using all of the data. And she's creating 224 by 224 image. And now she's using VGG16 with ImageNet pre-trained weights. She's getting, let's check, she's getting the loss of, after 8 epochs, she's getting accuracy of 0.97, validation loss of 0.20, and validation accuracy of 0.94. Don't exactly know how to compare this with our model. So this is the loss this is getting 0.1 point, which is much better than ours. 0.97, that means almost 97% accuracy. The validation loss is 0.20. It's way easy training it for 8 epochs. And what other parameters is he using? Category cross entropy, categoric optimizers, Adam accuracy. In this case, we are using error rate as our matrix. She's using 64 batch size. Callbacks, it's equal to early stopping. I don't know what that means. Our model is not done even with one epoch. We got 0.86 accuracy and 0.559 loss. Let's check other notebooks using fruit recognition using neural network. Let's check this guy's notebook. '81. Wait, is he using only 81 classes? Is he just using a subset of data or what? Let's check his loss. It seems he's not using a pre-trained model. He has created his own model. Hello, Zello Milo. Uh, what are you curious about? No, I'm not good at math. I'm just learning. You can totally say that I'm totally noob at this string. Are you also learning machine learning? Oh, you are a web developer then. Well, if you think about it, it's not that difficult. And the course I'm following, which is this one, FastAI, it totally it doesn't start with mathematics at all. It starts from, the top-down approach. It starts basically applying all the models to the data. And the course instructor says that you don't have to be that much good at maths to start applying machine learning. Like if you were to get into a PhD program or something, then you might need the basic granular layer of mathematics, but to apply this machine learning techniques, you don't need that much. Well, you can say that I was also doing web development before starting with machine learning. Well, not exactly web development. I have been dabbling in different things. Like exactly before getting started into machine learning, I was doing web hacking. So I was doing bug bounty and stuff. If you have heard about it, but I got bored with it, and therefore I started with machine learning again. It's been only, I guess, only a month or 2 months since I started learning machine learning again. Exactly, and I think that's why I kind of stopped doing web development actually. And if I tell you personally, I totally dread the front end part of it. I dread working with CSS and all that. Like I like the backend stuff, like all the logic and APIs and stuff, but I don't really like making the front end. So I'm also thinking of going back into it, like total backend development. Like I'm thinking of learning the Go development. So what tech stack are you using? Are you working somewhere? Like, do you have a job as a web developer or something? Oh, great. So previously I have worked with Node.js and I want to learn Go. So do you use both of them in your regular job? Because I'm also thinking of going into that direction of learning Go. So it might be helpful for me if you can tell me your experience and all that. Oh, you are learning Go. That's great. So it seems that most of the web developers I know are trying to learn Go now. Yeah, exactly. Joining the hype load. And I think that Go is, I am attracted to Go as well because JavaScript is not that much cool, and particularly the front end frameworks. Like there are so many frameworks that and my personality is like that I get into analysis paralysis very quickly. So that's why, like I have wasted like a month deciding what to use for my project, whether I should go with React or Vue. Yeah, TypeScript is, it's, yeah, everybody says that TypeScript is better. Just recently only I got a call from my previous employer. He said that he is using TypeScript now and he wanted me to go back to him and work for him. He's also using the TypeScript for backend development. Yeah, we can do web dev with Python. So anyway, if I make some models which are good and all, then I'm going to build a full stack project which will include the Python frameworks. Like I guess I will be using Flask for now to make a model, a full stack model. And if you are working in machine learning, you really can't get rid of Python at all. By the way, what do you think about the future of machine learning in Go? Yeah, I also think that. And just today only, I was looking at the job posting for Go developers, and most of them include Kubernetes and Docker and all those, infrastructure things. So they require this kind of things. And I think Docker is written in Go as well, right? Yeah, exactly. And if you know about Indian job postings, they are pretty much notorious in this case. Like they would give like pennies for everything. Like they need you to know each and every languages that are available in the market, and they will pay you pennies for it. Okay, so Kubernetes is also developed in Go. I think Docker is also developed in Go. Let me check it. Docker is written in the Go programming language. Yeah, so apparently Docker is also written in Go. So have you worked with Docker and Kubernetes and stuff? All right. Deployments in Kubernetes. Okay, cool. So by the way, what advice would you give if I were to get into Golang development? Yeah, exactly. That's the job of DevOps. And apparently most of the DevOps nowadays love Golang. Most of them are switching to Golang now. So this time we got 0.64 error rate. Golang will be good for backend since microservice architecture is getting popular now. Yeah, yeah, exactly. And actually that's why I want to get into Golang development, because you see, if I were to choose the JavaScript route again, most of them are for full stack developers, and they need you to know React and all that. For Golang development, most of them don't need you to know React development and all that. So that's why it moves in that direction, like purely backend. Exactly. And there are so many JavaScript developers that it's harder to. Yeah, it was cool before. Mm. Do you mean the JavaScript path was cool before, or the Golang path? JavaScript, okay. Great. That gives me hope, I guess. By the way, in other streams of mine, I'm trying to create a computer from scratch. Well, kinda having that. Yeah, I have come around this dilemma as well. Most of them compare Go and Rust, but I have kept my curiosity for Rust down because I know if I start to go down that rabbit hole of choosing between both of those, then I will fall into the analysis paralysis. Therefore, I'm not gonna even consider the Rust route for now. And on the Twitch only, I've come across many channels which, many tech Twitches are using Rust as well. Many companies uses serverless. By serverless, do you mean like Firebase and all that? Okay, okay, yeah, yeah. AWS. So even for those things, they need someone to maintain it, right? Like they at least need someone to maintain that infrastructure on AWS Lambda and all that. Yeah, I mean, yes, they provide or most of the functionality is provided by the provider as well. So yeah, that's correct as well. By the way, I don't find those things like configuring servers and all that much cool. Like I want to work with the backend stuff, but I don't want to get into too much, DevOps stuff. Yeah, exactly. I have tried cybersecurity before. That's what I'm saying. Before getting into machine learning, I was bug bounty hunter. Like I was not that much. Like I learned it for probably 6 months. Do you know what's bug bounty? Yeah, exactly that. So I did find a bug in but it was a self-hosted program. Like it was not on HackerOne or something. Yeah, then you report and then people will pay you. So that's a path as well, but it's a very uncertain path, and sometimes you hunt for days and days on end and you don't find anything. Yeah, exactly. It doesn't pay that much. Like there are this, star bug bounty hunters which like get millions of bounties, but they have been doing it for years now, and it seems that most of the program, like it is saturated. It gets pretty competitive because if someone finds it first, that means that you don't get it, and because most of the hunters are pretty much experienced by now, they find all the bugs, like they have all the automated processes and all that. That makes it very harder for beginner to get into bug bounties. And actually, and that's why I started hacking on this HackerOne programs, but I didn't find any bug. And then I tried a self-hosted program, which which pretty much comparatively has low number of hackers. But on the flip case, it doesn't pay that much. Like I found a very pretty severe bug, and they basically paid me pennies for it, and that's why I got discouraged and I thought it's not worth it, and that's why I left it. And besides bug bounty in cybersecurity, most of the stuff is pretty much I find it bureaucratic, like all the blue teaming stuff doesn't interest me that much. It seems like most of it is just following protocols and all that, which I find it pretty boring. Yeah, yeah. Well, there's this thing called city apps. City apps, if you know about it, capture the flag. These are the vulnerable targets, and you have to hack them. So those are pretty much fun, but they are not as they are not the real targets. That's not you are not learning anything anyway. You don't learn hacking unless you work on the real targets. So if you want to, if in future, if you want to check out hacking, start with city apps or something if you are interested. So are you a self-taught developer, or did you go to a boot camp or college or something? A CSE degree, computer science degree? What was it in? Was it a computer science degree? Well, yeah. Actually, I attended university, but I dropped out after 2 years. I was also into computer engineering, but I only did 2 years of it and dropped out because I also thought that the learning method was not that much efficient, and the lectures kind of seemed boring to me. Like there was not much practical application and stuff. And in this IT field, I guess that you can get by without a degree pretty much easily. Like if you can show the employer that you have the skills. Teach you to memorize, not to learn. Exactly. I mean, if I tell you honestly, after dropping out only, I have learned exactly how to learn. Like I have read numerous books on learning how to learn and all that. And I have gone down that rabbit hole of, teaching yourself different skills. And I found out that the university approach was not efficient at all. And that's also the reason why I am doing this course, Fast AI. So this course goes against the approach that is mostly taught by the schools, which is bottom up approach. Book for what? Learning how to learn. Well, I don't have any names on the top of my head, but I have this. The most impactful method I found was this Dreyfus method. There's also a book, I guess, but the Dreyfus model of skill acquisition. And the authors of this paper has also written a book, I guess. So the thesis of basically is that it provides, totally granular approach of learning something. Like it shows how to go from a novice to an expert. It signifies all the different stages. So there was this one, and other books let me think. Learning how to learn. I also came across the course on Coursera, but I found out that that course is not that much good. Learning how to learn, like it focuses on memorization and all that too much. This course focuses on memorization a lot, like chunking methods and all that. So you can say this course is good for the university guys. And there was this book called, I guess, Learning Skill in 20 Hours or something. Yes, by Josh Kaufman, How to Learn 20 Hours to Learn Anything. So that was this guy. And other books were, let me think. There's also this blog. Well, I have a separate folder for learning stuff. Well, right now I have 100 Mbps connection, and I'm paying like 700-800 rupees. So that means 800 converted to dollars. Like 11 or $12 a month for 100 Mbps connection. And I get 1500 GB per month, which is I find more than enough. uh, how much do you pay then? $40. Oh, to pay $40 with 100 Mbps. Is it unlimited or limited? So these are all the bookmarks, I have taken for learning unlimited. So mine is limited. You can check out this blog as well. This guy is also very much pro, you know, self-education and all that. Teach yourself anything with sandbox method. So that's this blog post. And other good blog post. This guy is Scott H. Young. Yeah, so this guy recently wrote a book. This guy recently wrote this book, Ultra Learning, which is all about learning how to learn. You can check that one out as well. That was the last book I read on learning how to learn. Yeah, welcome. You see, as you can see from this bookmark, I have gone down the rabbit hole of education system as well. So how it was made and all that. Yeah, exactly. As I told you, I have gone down the rabbit hole. There was a time when, for months on end, I was just researching how to learn and how the colleges and education system teach students and all that. And you know what? I think most of the tutorials on the internet are also useless. Like if you were to follow those tutorials, you won't get that much skill. Like you have to make the jump and create your own projects. Then only you learn you. Yeah, exactly. The tutorial help. And when I dropped out, I spent almost 5 to 6 months in tutorial help. I was, jumping from one JavaScript tutorial to another JavaScript tutorial. Then finally, I pulled the trigger and I said, I'm gonna build a web app. That's it. And even if I don't know how to use database and all that, Node.js. So exactly, even that's how I learned Node.js and MongoDB. Like I had not used or I had not previously learned about it, but I just started building the project and tried to learn it as I go and as I try to build it. So that's how I learned how to use MongoDB database and all that. and the feeling, it was totally different. Like you learn on accelerated rate. Like you are finding, if you are stuck for, that day, whole day, and you finally find the answer. Feels uh, different, totally different. 79. Yeah, sure, man. It was good chatting with you as well. Bye. Thanks for the follow. We got a rather bumpy graph this time for the learning rate, but we did get down to 0.75, 0.69. Well, for just the basic fine tuning, we got up to 0.59, so which was better than previous case. Alright, so for the custom fine-tuning method, we are getting up to 0.77, which is rather same for all the cycles. And this is for the DLRR. So let's first save this model. Now let's try to use the discriminative learning rate, and we will use the same thing. It's good, it is training much faster this time. So it seems Google Colab is not throttling us up now. I mean, not throttling. Good, we got down to 0.65 error rate. We can't say much because this is for the random layers. Yes, we have still this fit cycle left. So this guy is getting accuracy of 0.97. Right, I got 0.68 error rate on the first epoch. 0.62. And 68. Let me check what this matrix error rate represents. Error rate. It's not inside this notebook. Error rate. Error rate. Diminished distance. So the error rate is fluctuating, in the same range, like it is going up and down and up and down and up and down. And the validation loss is not decreasing as well. But the training loss is decreasing. That means we are definitely overfitting the model. Batch accuracy. Alright, so this time our model got down up to 0.61 error rate. Where we got up to that much in the fourth epoch. Got 0.62. 0.64. Let's plot the loss as well. Oops, the training loss is almost flat, and the validation loss is like going down, up, going down. That's what I said earlier. It's like fluctuating up and down, up and down. We want check. We want this kind of graph ideally, but our model did improve a bit since we added some more data. So I guess if we were to use some more data, we might get a better working model, I guess. Cross entropy. What if I were to use Resonate 50 now? Let me try to run Resonate 50 for our newly created dataset. First of all, we should save this model. It was custom fine-tuning, right? With discriminative learning rates. Should be 4.1 custom. Okay, it has been saved now. Let's run Resonate 50 now. And 73 error rate. All right. I'm pretty much hopeful this time that if we were to use all the data, the whole data set that we have containing 90,000 images, then our model will definitely improve. But yeah, it is going to take a hell lot of time to train on that data, because we are down to almost 0.64 to almost 60%, 0.60 error rate, I guess, 0.61. So if we were to use some more data, we might see, wait, maybe this is not improving because of the lower learning rate. What if we were to tweak this learning rate? Previously we found that the loss was improving for this learning rate range. So that's why we choose this value. What if we were to choose 10 raised to minus 2? which will be basically in the middle of the slope. That might increase the learning rate and thereby decreasing the loss drastically. This time we are getting 66 on the first epoch, about 72, not that much difference, still a bit of improvement. Point 59, that's new now. And we have got up to 2.26 validation loss. That's also a bit better. And this time we are only using, let me check, we are just using 0.2, 20% of the 90,000 images. So we are using just 6,000 images and we are getting this kind of results. We still have, almost 80 to 82,000 or 84,000 images left, almost 80,000. So if we were to use all those images, then our model will improve a lot. Cool. So it seems using a resonate 50 does improve our model. We are getting up to 0.55 error rate and 2.24 validation loss. So this validation loss is not improving that much. Let me check other notebooks. This guy was getting up to 0.05 validation loss, but he's using all the data and we are just using 20% of data. It seems our model has started to overfit. Yeah, we got up to 0.56 this time. Let me save this model as 5.5. Let's plot the confusion matrix. So now we are starting to see a somewhat diagonal line. Previously we couldn't even see this kind of diagonal. Still the data, it seems the data is not that much to predict. Which are the most confused? So there are a lot of confused classes. Culberry, grape white, grape pink. 28 of them were confused. So now I think I am of the opinion that if we were to increase the data, we will get, if we were to increase the data, we will get a better model. But in this stream, I'm gonna not do that. We'll try to improve this model further in the next stream. I think this is enough for this stream now. So in the next stream, we will increase the dataset size. So I will off stream, I will try to fetch the missing data. Like we only have 65 categories only. We have lost the remaining data. So I will try to download it off stream and put it inside the Google Drive so that we don't have to wait it on stream. Alright, then this is it for this stream, guys. I will see you guys in the next stream. Bye bye.